Good morning, everybody. The title given to me was Converting Past and Present Findings in the Animal Model to Clinical Practice in Humans, Myth or Fact. So it's such a long title. So basically, I'm going to talk about this little bit on what's the clinical status of the kidney stone disease and how the animal models have helped in this. So let's just see this thing, the clinical data. In 1940, Randall suggested that there is basically the formation, there are two kinds of plaques in the papilla, which is a pathological condition of the papilla, which one of them is called Randall's plaque, type 1, which is a subepithelial deposit of calcium phosphate or calcium carbonate. And the other type, he called them type 2, which was excessive urinary supersaturation and tubular necrosis. So those were the two types of lesions. Both of them could work as the precalculus lesion. Now this is the current status. I have two things here from Dr. Coe and Dr. Williams. Dr. Coe is talking about that the supersaturation of calcium phosphate and calcium oxalate in the urine and local to the papillary interstitium foster the formation of interstitial epithetic plaque. Supersaturations also create tubular plug, but exactly how this process occurs and whether the tiny overgrowth found on plugs become clinically significant stone is unknown. That was 2016. Now in 2021, Jim talked about it, and he says growth of many small stones on plaques seems the pathogenetic scheme for the Randall plaque associated stone forming phenotype, whereas the non-Randall plaque phenotype stone pathogenesis pathway is less obvious. Higher papillary plugging in non-RP suggests that plugs play a role in stone formation. Underlying mechanisms that create these distinctive phenotypes are presently unknown. So now we know two things, or three things, that the supersaturation and crystallization are important part, that there are Randall's plaques and plug, and then plaques and plugs exposure to the pelvic urine starts the stone formation. So now, coming to the animal model. So how do we actually prove the points that have been raised or answer the questions that have been raised by both Fred and Jim? So of course, animal models, as I think Dick Koch was suggesting, you cannot experiment on humans. So we do this work in the animals. And most of the work that I have done is in rats and mice. And in both cases, for example, we increased hyperoxaluria in rats or hypercalciuria in knockout. And in both cases, whether it is a calcium phosphate deposition or calcium oxalate deposition, it is happening in the tubules, as you can see here. These are tubular lumina. There is a calcium phosphate on one side and calcium oxalate on the other side, and both of them are happening in the tubular lumen. So crystallization within the kidneys and crystal retention are two separate events. Urinary supersaturation leads to crystallization within the renal tubules and not the interstitium. And here is the distinction between the type 1 and type 2. Then another studies in the animal models where they have created genetic modification animals with osteopontin knockout, Dem-Horsfall knockout, ABCC deficiency. So in all these cases where there is an inhibitor deficiency, there is a deposition of calcium phosphate in the interstitium, as you see here. There is one from 2010 on a THP knockout mice. On the other side is ABCC6 deficiency, which leads to the deficiency of pyrophosphate. So we all are familiar with all these. They are supposed to be crystallization modulators. So then move on to the next, that okay, if these are the modulators, how do they are regulated? And we studied it and we have published it in a number of articles that reactive oxygen species regulate the activation of genes of inhibitors, macromolecular modulators of crystallization such as osteopontin, biquinin, fetwin, calgranulin, inter-alpha inhibitor, matrix block protein, and TEM-Horsfall protein, etc. Now, the important part here is, and you heard David mentioning earlier, crystallization modulators, all those that I just mentioned, except maybe TEM-Horsfall protein, which is questionable, that they are also a part of inflammatory process. So then, further, when you look at the kidneys of the hyperoxaluric and hypercalciuric animals, they show signs of osteogenic. And those osteogenic changes, anybody who is familiar with the literature on vascular calcification, generally you will find out they talk about fetwin, they talk about matrix block protein, they talk about osteopontin. Those are very common, and those are very common things also in the literature on calcium oxalate kidney stones. So what do we get from this lessons from the animal models? Animal model studies provide affirmation of Randall's proposals. Deposition of crystals into terminal collecting ducts that lead to blockage of their openings is similar to the development of Randall's type 2. Deposition of calcium phosphate in the interstitium in the absence of certain crystallization inhibitors may be similar to the development of Randall's plaque type 1 or Randall's plaque as they are currently known. So animal studies provide possible mechanism for the development of Randall's plaque, further proof of the role of supersaturation in the formation of plugs, proof of the efficacy of dietary modifications. That is something we just heard earlier when Dick was talking about it, and also earlier than that when we were discussing whether kidney stone is a specific disease, that there is a certain diets which, and particularly the Mediterranean diet, which is supposed to be recommended for hypertension, etc., they also have an antioxidative regime in it. So now we go back to the clinical data, and here is the paper that Dr. Goldfarb and Dr. Eisner published, and it says the symptomatic recurrence rates are about 11% at 2 years, 20% at 5 years, and 31% at 10 years. Stone farmers to change, so the recommendation to the stone farmers is to change their diet, low sodium, low animal protein, normal calcium, and drinking habits, fluid consumption of more than 2 liters a day in an effort to decrease the rate of recurrence. Now go back to 1944, last century. Randall, when he published this, his thing was the calcium phosphate stone makers are to be studied to ensure a well-balanced diet, and taking of large quantities of water daily is perhaps the surest answer to our question of prevention. For given a dilute urine, there is little likelihood of sufficient concentration for any salt to be deposited as crystals, whether there be a nidus or not. But I believe the regular ingestion of at least 2000 cc of water daily are paramount. So, back to the future, drink a lot of liquids. That's the answer. Thanks for listening.